We'll now talk about forward rate agreements. And I hope you remember from level 1 that a forward rate agreement is an agreement on an interest rate. So if you are sitting here at time 0 and you agree on a rate at some point in the future, then that is a forward rate agreement. In level 1 we talked about the forward rate, and even at level 2 in fixed income we've talked about forward rates. We will again derive the forward rate, but the new element here is that we'll also talk about the value of the forward rate agreement over time. So let's take a very simple scenario. Consider a forward rate agreement which expires on day 270 and the underlying is 90-day CIBOR. CIBOR is the Karachi Interbank Offer Rate. It is somewhat like LIBOR. You are given the 270-day CIBOR and you are told that the 270-day CIBOR is 10%. So this rate is 10%. All numbers given here are annualized numbers unless you are told otherwise. You are also given 360-day CIBOR, which is 12%. Recall from level 1 that the terminology of this FRA is the following. So you need to write something times or by something. The first something represents when the hypothetical underlying loan starts. In other words, this is the point where the FRA expires. So 270 in terms of months would be 9. The convention with forward rate agreements is to use 360-day years. So 30-day months, 360-day years. This is 9. And then the second element here is where the underlying hypothetical loan ends. That is 360, which is month 12. So the terminology is 9 by 12. Now what is this forward rate? The way you think of this is, if you invest at 12% over the entire period, the amount of money that you will have at the end should be the same as investing for 270 days at 10% and then investing again for this 90-day period. So let's say X% is the forward rate, and again all these numbers are annualized. So what is the equation that we can create? We can say that 1.12, so $1 or 1 rupee invested here will become 1.12 at the end. This should be equal to 1 plus 10%, which is 0.1, and this needs to be de-annualized. So how do you de-annualize? You multiply this by 270 over 360. We are using 360-day years. And then this needs to be multiplied by 1 plus, and this X% is the forward rate, and this is an annualized number. So X into 90 over 360. You solve for X and you will get the annualized forward rate. If you do the calculation, what you should get is X equal to 0.1674, which is 16.74%. So that is the forward rate. Now just a few points to make sure you understand the conventions being used and some intuition. Notice that this 12% is the 360-day CIBOR, which is much higher than the 270-day CIBOR. Just looking at these two numbers, you can tell that this number would have to be much higher than 12% to bring up the overall 1-year rate to 12%. So the fact that you are getting 16.74 should not surprise you. That's one point. The other point is that the convention used with FRAs is that we multiply the annual interest rate by a fraction. We do not use exponents. Unless you are told otherwise, with FRAs, we use this simple method to annualize and de-annualize. Again, it's just convention, the curriculum does it, so that's what you also need to do on your exam. We are now going to talk about the value of a forward rate agreement. The first slide is something that you've actually seen before multiple times. You've seen it at level 1 and you saw it in fixed income, but this is new. We move forward 90 days. So this is where the contract was initiated. Now we are here, day 90. Interest rates have changed. 180-day CIBOR is down to 8% and 270-day CIBOR is 9%. What is the value of the forward contract assuming a notional principal of 100 million? All right, so we are told that 270-day CIBOR is 9%. So this is, we are at day 90. So this is the 270-day CIBOR, 9%. We are also given the 180-day CIBOR, that is 8%. So the question is, what is this 90-day rate given the new interest rates? We use the same calculation. We say that 1 plus 0.09, and now this is not 1 year, so it needs to be de-annualized. 1 plus 0.09 into 270 over 360. This needs to be equal to the 8% number, 1 plus 0.08 into 180 over 360 multiplied by, now X is the new forward rate given the lower interest rates. So 1 plus X into 90 over 360. What you should get is 0.01058 or approximately 10.58%. So this is saying that the forward rate has come down. So the long party is actually losing. If a long party locked in that higher rate that we showed on the previous slide, now with lower interest rates, the long is losing and the short is winning. But by how much? So we need to take a difference. The difference would be between the original forward rate. Actually, let's do it from the perspective of the long. So from the perspective of the long, we take the difference, which is 0.01058 minus the original amount, the forward contract rate, which was how much? 0.1674. Remember, all these numbers that we are talking about are annualized numbers, but our loan is a 90-day loan, the underlying hypothetical loan. So for the 90-day period, this needs to be multiplied by 90 over 360. And then since we are trying to find a value, we multiply that by the currency amount, so 100 million rupees. And you should come up with your answer, which is minus 1.54 million. This is the value for the long. And again, it makes sense that it's negative because rates have gone down and the short party is winning. Now we move to expiration. And on expiration day, 90-day CIBOR is 8%. So expiration day is 270. This is where the forward rate agreement expires. Here the rate is 8%. What is the payoff for the long party? What we do here is say 8% or 0.08 minus the forward rate, which was 0.1674, and this needs to be de-annualized. So again, multiply by 90 over 360 and multiply this by 100 million, and what we should get is, so minus 2.185 is the value here at the end of the hypothetical loan, and you studied this at level 1 also. We want the value over here, so we need to take this number 2.185 million and discount it back at the market rate which is in effect at that point in time. So you will then take this number 2.185 million and discount, and how do you calculate that number? It would be 1 plus 0.08 multiplied by 90 over 360. Since we are dealing with FRAs, we still use this convention. And when you do the calculation, what you should get is 2.142. And again, for the long, it's going to be negative. For the short, it is positive.